I'm going to take a look at a question like this. You've got a production line producing cans of drinks. The mean content is given, so the mean is 332, and I'm giving you a bit of information about a probability. 65% of the cans contain less than 333.5. I'm asking you to find the standard deviation. So this is a question that I can't use the calculator yet because I don't know what the standard deviation is. So I need to use the standardizing technique to help me with this. First thing I'm going to do is put the given information onto a sketch. Sketches are always good. So 332 is the mean. The probability information, 333.5. I know that the area to the left of that is 0.65. That was given. I'm also just going to remind myself that this is x is the normal distribution, 332 is the mean, and the variance, sigma squared, is unknown. So with that information, I'm stuck. So what I'm going to do, I'm going to standardize to the z distribution. Z is normal distribution 0, 1, which I know is centered on 0. And I know that the areas will be preserved, so that the area to the left is still going to be 0.65, as long as I convert with the formula z is x minus a mean divided by a standard deviation. So I'm going to calculate the corresponding value of z using this formula. So z is going to be, x was the 333.5, subtract the mean, which I know is 332. You see the diagrams are helping me get all these numbers in the right places. The standard deviation is unknown. So I've got that, I can simplify that, that's 1.5 over sigma. But the good thing about this, of course, is that I also know that if I use inverse norm now, then I know that the area to the left of this z value is going to be given to me by asking for that on the calculator. I know the mean and the variance for this distribution. So I can use inverse norm. It will tell me that that z value turns out to be 0.38532. So I know that z, which is, sorry, let's go 1.5 over sigma, is equal to 0.38532. And of course, from there, it's a very simple step to finish that off and figure out that the standard deviation is 3.89. So we're just taking a look at those steps. Standard deviation is unknown, so I can't move forward with this distribution. So I standardize it to a distribution that I do know using the formula that I'm familiar with. I get an expression for z, and using inverse norm, I know what that expression is equal to, and I can solve the problem. Now, it's also a common question for you to be in a situation where both the mean and the standard deviation are unknown. So let's just take an overview of how this might work. If I've got x is normal, mu and sigma squared are unknown, let's continue as from the other one, 333.5. And remember I told you that the area there was 0.65. I carry on just as I did before. This would then be z is normal 0, 1. That's 0. This conversion now with z is x minus mu over sigma, of course, would become 333.5 minus the mean's unknown, and so is this. Because I know that that area is still 0.65, I can still use inverse normal to tell me that this was equal to 0.38532. So of course, what I've got here, I'm probably going to rewrite this, 333.5 minus mu is equal to 0.38532 sigma. I'm going to put a box around that and call it number 1. One bit of information leads me to one equation. If you've got a question with mean and sigma unknown, they need to give you 2 probability facts. So what I would do at this point, I would then take the second probability fact that they give me. It might be to do with the probability being less than a number. It doesn't matter. You can go through exactly the same process and arrive at another equation of the same structure. And of course, as soon as you've got 2 equations and 2 unknowns, you can solve them to find both the mean and the standard deviation.